Our next speaker will tell us about her journey in IT. She's a great person and amazing engineer, whom I had an honor to meet a few months ago. A happy mom of 2 daughters who loves reading and gardening. With a speech, up into the clouds, let's get virtual. Iuliana Chitu. Iuliana, over to you.
Hello everyone, my name is Iuliana Chitu. I am an engineer working for NOKIA and I live in Timișoara, Romania. I am honored to be invited to this event that gives young women the opportunity to find out about other fellow women's experiences in engineering and technology, allowing them to decide in better understanding how their future can look like. I would like to introduce myself now. Right after graduation, I have joined Alcatel, a telecommunication French organization, over 23 years ago. As you may know, NOKIA acquired Alcatel-Lucent in 2015. Even though I hold a bachelor's degree in software engineering, I have embraced the chance of working in telecom industry. Back at that time, the software industry was at the very beginning in Timișoara, and there were no opportunities for students to work part-time jobs as there are now. Situation didn't get better after graduation, as there were no job shops, no LinkedIn, no job advertising at the end of our fingertips because, surprise, there was no internet as we know it today. If you wanted to get yourself informed, all you had to do was to go and buy a newspaper and search in advertising section. So I've started as an integration engineer in the fixed switch department, then changed to optical networks as part of a software development team working on Alcatel 1678 optical cross-connect switch. The next project for me was to design and develop text-to-speech plugin used by Alcatel Specialized Resource Point to speak the announcements for the Voice Intelligent Networks services. Further on, for almost a decade, I was a customer development engineer for a project management tool called Matrix, like the movies. It was mainly used by the external telecom customers to manage and control their mobile GSM rollout projects, 2G and 3G. This role required a wide range of technical and soft skills. Part of the activities was mostly performed on client side, while the other part was done remotely. Therefore, I have had some international assignments in several European and Asian countries. I enjoyed being part of many challenging projects and working with wonderful people, both in the team and on customer side. Unfortunately, Matrix reached end of life and our team moved to a totally new project in software-defined networking domain. After some months of training on the new technologies, we were assigned to a northbound interface application where a new module and business flows needed to be implemented. This project ended as well. My actual job is to deliver NOKIA SDN NFV, software-defined networking and network function virtualization solutions to different telecom customers. This field is in full evolution as the pandemics increased the amount of internet traffic to unprecedented level. I'm currently on a new learning path for several months, and I am happy to share the top of the iceberg with you. Besides being a NOKIA engineer, I'm a mother of 2 lovely girls. I'm a passionate reader. I love traveling and gardening. Now I will present you the evolution of data centers during the last years and how the technology has changed the way computing resources are used. Let's start with the first notion. What is the purpose of a data center for an organization? Well, a data center is a large collection of compute, memory, storage, and networking resources used for the remote storage, processing, or distribution of applications and large amounts of data. Originally, all machines in a data center were sitting in a dedicated room and they were performing a specific activity for the same organization as running different software programs and storing data. The organizations had to invest big amount of money to build and operate information technology infrastructures as IT operations became crucial for business continuity. This arrangement was functional for some years, more precisely up to year 2000, when virtualization became a popular word and the first virtual machines were released by VMware and IBM. Let's define virtualization. This is the act of creating a virtual version out of a physical resource. We can virtualize memory, storage, network, even software applications and data. Virtualization is not something new, as it was created earlier, back in the 1960s, as a method of logically dividing the system resources provided by mainframe computers between different applications. A virtual machine is the virtualization of a computer system. VMs are based on computer architectures and provide the functionality of a physical computer. Each VM can be dynamically assigned to different tasks. A physical machine can be subdivided into several VMs sharing resources. Also, the physical machines can be shared on demand among different organizations known as tenants. To help you better visualize this concept of virtual machine, I will use an example from the movie The Matrix Reloaded. There's a famous scene where the main character, Neo, fights Agent Anderson, the bad guy, and suddenly this one starts cloning himself hundreds of times. Though they were all copies of the original Mr. Anderson, each one of them were able to do different things at the same time. This is just like the creation of more virtual resources out of only one physical resource I was talking about earlier. This virtualization technology pushed new requirements towards the data centers, so they have begun their evolution from a rigid and static structure to a flexible and dynamic one. First, a physical machine, called also a server, could be subdivided into several VMs with shared resources. Each machine should be able to be dynamically assigned to different tasks. Physical machines could be shared on demand among different organizations, also known as tenants. The virtual machines could be easily migrated without loss of service. A side effect would be self-healing. When a VM was down, another one could take its place very quickly. The VM configuration would be minimal, allowing fast scalability. So a new business model was born, and its name was cloud computing. A definition of cloud computing sounds like that. Cloud computing is on-demand access to resources over the internet that can be rapidly provisioned and released with minimal management effort or service provider interaction. There are two types of players on stage: customers and service providers. A cloud computing service provider owns a pool of computing resources. The customers, instead of incurring the cost of purchasing their own equipment, use the service provider's computing resources as needed. This cloud model promotes availability, and it has 5 essential characteristics. Broad network access. Services are offered over the network and accessible to a variety of client platforms: cell phones, tablets, laptop, etc. On-demand self-service. This is pay as you go. For instance, a user needs a VM for 2 hours, so he will pay to use the VM for the next 2 hours. All is done automatically. No human operator stays behind. Resource pooling. Storage, processing, power, and bandwidth are shared among multiple customers. This is the multi-tenancy we were talking about earlier. Rapid elasticity. The cloud can scale rapidly outward, inward to accommodate demand. For example, a Black Friday event for an online shop will increase the number of clients. Therefore, the new VMs will be allocated automatically. Once the event is finished, the VMs are released. And the last one is measured services. The cloud collects meaningful information that provides resource usage monitoring. The cloud computing comes in several service models. Comparing with traditional IT structure, where customers owned the whole pile of resources, each of these new models are built accordingly with the customer's needs. Let's take them one by one. First goes infrastructure as a service. Everybody must have heard about Amazon Web Services, DigitalOcean, or IBM Cloud. They offer server, storage, and network transparently to the customer, while the customer brings on the OS, the development platform, and the applications with data, all for the needed amount of time. Second is platform as a service. Here we have Microsoft Azure, Google Cloud Platform, Amazon Web Services Lambda, Rackspace. They provide a development environment that can be used to build a web application and then host it and running it, and without having to deal with installing a database, a software development kit, scaling the application, managing the operation system. The client runs the platform, uploads its application source code and data, and deploys the application, but it does not have to care about maintenance and scalability of the environment. Third and last is software as a service. Who doesn't know about Gmail, Zoom, Dropbox, Google Workspace, Netflix these days? Here, the service provider runs its application on the internet while the clients pay a recurring fee to use the applications or no fee at all. The best part of SaaS applications is there is no need to install and maintain the software. One can simply access it from the internet and use it without worrying about complex hardware and software management. Physically, the cloud is a data center in which your virtual machines run, yet someone else is managing them. There are 4 cloud deployment models: private, community, public, and hybrid. I will explain them one by one. Let's start with the public cloud. This is an infrastructure owned by an enterprise selling cloud services, and it can be useful for startups or small to medium businesses to rapidly set up a web service by renting compute, storage, and networking. Multi-tenancy is a fundamental aspect of the public cloud. The cloud provider owns and manages the infrastructure and rents it to thousands of customers. Amazon Web Service is by far the biggest public cloud service provider. They initially started as Amazon simply wanted to improve their own IT environment. And here they are now. The next would be the private cloud, the opposite of public cloud. This is an infrastructure owned and operated solely by an organization. For large enterprises, security of business data and regulatory constraints is very important. It is more difficult to use public cloud. Private clouds reproduce the characteristics of a public cloud within the enterprise by having a flexible computing platform to provide compute, storage, and networking in-house, all behind a firewall. Public clouds benefit from economy of scale by sharing resources across many customers, which might not be the case for a private cloud. But cost reduction is only one factor. Speed and agility to deploy services to the internet is important as well. Hybrid cloud is an extension of the private cloud into the public cloud. For example, An enterprise's day-to-day operations run on the private cloud, but initial launch of a new product runs on infrastructure rented from a cloud service provider. We can identify two use cases. Use case 1, keep sensitive data in the private cloud, but the user-facing application is deployed in a public cloud and it has access to the data from the private cloud using a firewall, of course. Use case 2 is cloud bursting. Normally, applications run in a company's own data center, but in cases of high demand, extra servers can be deployed in a public cloud to manage it very quickly. Community Cloud is a multi-tenant platform that is accessible only for a specific subset of customers. It enables collaboration among organizations and builds community spaces to connect. Examples include universities cooperating in certain areas of research or government agencies and enterprises. They all have common challenges and common opportunities. By joining forces and helping building a community cloud that serves their purposes, they will benefit of way better solutions at a lower cost. So, the two main requirements of a cloud computing are they must be able to handle very dynamic workloads and they must support virtual machine migration with minimal disruption. How can this be achieved? There are two entities that need automation: the virtual machine instantiation and the virtual machine network interconnection. To help you visualize the two entities and their relationship, just imagine that the VMs are buildings while the network can be represented at the roads and highways that interconnect them. The data travels from endpoint A to endpoint B, and there are rules established by networking protocols, the so-called IP routing protocols, that are regulating the data traffic. The cloud management system is a tool used to automatically instantiate virtual machines. Examples of cloud management systems are CloudStack, VMware, and OpenStack. The software-defined networking is a tool used to automatically create and maintain the networking infrastructure required by newly instantiated VMs. The most important players in SDN are Cisco, VMware, Big Switch, Juniper, and Nokia. Let's focus now a little bit more on SDN and NFV, as this is part of Nokia portfolio. The legacy data center network architecture is not suited for cloud computing deployment. It is too slow for on-demand services and not optimized for cloud application traffic patterns. SDN is a network architecture approach that addresses these issues. For example, SDN with this northbound API provides a way for a management platform to program the network. The network control is decoupled from forwarding plane and is directly programmable by the service provider via a centralized SDN control software. The SDN controller functionalities are interacting with applications and network layers through programmable APIs such as OpenStack and protocols such as OpenFlow, providing global provisioning of network services devices through a complete view of the network, and implementing homogeneous policies on network devices and switches and routers. On the right side, you can see the transformation that NFV is bringing to a classic physical network function. A PNF is a service, for example, a firewall, that is a software running on a dedicated hardware. What does NFV to a physical network function? It separates it to three layers. The first is hardware resources also called commodity of the shelf. This contains computing, storage, and network, exposing the resource APIs, for example, create VM, create network segment, and so on. The next layer contains the same components, computing, storage, and network, but virtualized. These two layers together are called virtual infrastructure. Finally, the last one is the virtualized network function, which would be our service. Of course, there is a virtual network function manager that deals with the life cycle of any VNF. NFV intends to bring cloud computing benefits to telecom operators. It refers to running a network function over commodity hardware within one or more VMs and having an orchestration platform to manage them. NFV realizes significant cost savings and operational simplification for service providers through automation. NFV and SDN are highly complementary. SDN automatically creates, orchestrates, and manages virtualized connections between VNFs and PNFs. Finally, I present you in a few words the NOKIA Data Center Fabric solution, which is an automation and operations toolkit that delivers agile and scalable network operations for data center and cloud environment. As you can see, it is comprised of three significant components. The 7220-7250 IXR built-in-house family of routers are designed and optimized for the data center network. Service routing Linux is a key component of a NOKIA data center-focused networking solution that delivers scalability, flexibility, and ease of operations for data centers and across hybrid and multi-cloud environments. As its name says, it uses unmodified Linux kernel, simplifying use of non-NOKIA applications. Network Operations System uses modular, state-driven architecture, which gives open-source CLI plugins written in Python power to complete customization. NetOps Development Kit, NDK, supports integration of third-party applications. Streaming telemetry allows retrieval of detailed system state. The Fabric Services System supports intent-driven network design and automated operations. The first version of NOKIA FSS and SRL was launched last year. In the end, I want to encourage you to dare and make a smart choice for the future. You are young and you have fresh ideas that may have an impact. Engineering looks hard and it's a male-dominated field. However, many women had important contribution to engineering over time. There is a strong gender stereotype that contributes to the underrepresentation of women in engineering. You can break it and follow engineering without fear. One point of great importance in one's career is the opportunity to constant learning and keeping up with the new technologies. IT and telecom exponentially developed in the last years. More than half of available technologies we have didn't exist like 15 years ago. NOKIA provides both the time and means for its engineers to access all the knowledge they need to perform their jobs at their best. From my perspective, NOKIA makes no difference in hiring men or women. Here in Romania, we are 37% women in the company, a quite high rate comparing with other regions. While cultural biases may exist outside NOKIA offices, NOKIA policy is to always provide equal opportunity for all candidates, no matter of gender, race, or religion, ethnicity, age, or other factors. There are highly professional people in the organization, and I am glad I've met some of them and I had the chance to learn from them. In return, I was happy to offer mentoring to younger colleagues in their beginnings. The teams I belonged to were amazing, and we remained friends even after I moved to another project team. Thank you for your attention. I'm wishing you all the best. Good luck in your journey, and who knows, maybe we will virtually meet someday at Nokia as colleagues.
Thank you, Iuliana, for this great speech. Now let's move to the next presentation.